Good morning, everyone. My talk today has a title Automated Paddy Field Map Generating from Spot 6 Satellite Image using Pyramid Scene Parsing Net Model. So let me briefly introduce. My name is Yaya Heryadi. I am a lecturer and researcher from Binus University, okay, which currently has uh, built a campus in many locations, including Greater Jakarta, Bekasi, Bandung, and Malang. Let me start with basic concept. First of all, is paddy field map is a map of paddy field. Okay, in bahasa Indonesia we call it sawah. In this study, map of paddy field generated from remote sensing imagery. Paddy field map generating is basically a term referred to automated generating of paddy field map from remote sensing image, including satellite imagery. And semantic segmentation is a term refers to process of assigning semantic label or object classes to each pixel of an image. Semantic segmentation is an important problem to be solved in Geo-AI or Geospatial Artificial Intelligence because it can simplify image representation into a form that is easier to analyze or interpret. There are some factors contribute to the increasing research interest in semantic segmentation using satellite image, including wide availability of satellite imagery and the advent of deep learning technology in the past 10 years. However, satellite image-based semantic segmentation is an easy problem to be solved because there's some challenge to be handled by researchers, including high object complexity, cloud partial occlusion, to make the object is sometimes unclear partially, and larger image size than the computer memory can store and can hinder accuracy of the image segmentation result. What I mean is that the size of satellite image is certainly is bigger than the computer memory can handle. So that's why in research involving satellite image analysis, we need to adopt partition technique of the input image. All right, so semantic segmentation is basically classification problem. Okay, so the data for these algorithms, okay, to solve semantic segmentation is basically a label data set comprises of data and a label, and the label is typically built, okay, for each data set by an expert. So labeling data is handled manually. And semantic segmentation training models is basically a process to choose the best approximated models for a mapping function from data to label using learning algorithm, which basically is optimization problem to object function. Yeah, here is the objective function is cross entropy, and then by learning algorithms such as stochastic gradient descent, ADAM, and many more is basically to obtain the most optimum model parameters. All right, so as the research framework, so as I said before, semantic segmentation is basically a classification problem. So here we use supervised learning, to train the model. And in this study, the data label is limited to paddy field and non-paddy field. And training data set consists of 27,170 ground truth patches with 256 times 256 and 3 pixel of each patches. And then in training model, we split the input data into two parts. First of all is training data set comprises of 80% of the total input data, and testing data comprises of 20% of the input data. In this study, we explore pyramid scene parsing net, or sometimes it's this model is called PSP net. And this model is trained using Adam optimization algorithm with weight decay. And the objective function is cross entropy. And we adopted early stopping as a regularizer to avoid overfitting. And we use accuracy as the main performance metric. Okay. So this is the map of the study locations and some of the ground truth sample provided by Badan Informasi Geospasial. And from the architecture perspective of PSPNet model, which is proposed by Zhao and et al. In 2017, consists of three parts. First of all is convolutional network. Is a network basically to produce feature map from the input image. And then there is a pyramid pooling modules to extract different subregion representation, followed by upsampling and concatenation layer to form the final feature representation. And this feature representation carries both local and global context information of the object. And finally, convolution layer is used to generate the final per pixel prediction of for classifications of the pixel. So in this study, the total parameters of the PSPNet is 38 million. So it's very big model architecture to be trained. Consists of 37 million trainable parameters and 1 million non-trainable parameters. Okay. This model was trained using Adam optimization algorithm using weight decay to optimize the objective function, which is cross entropy. And then early stopping is implemented to avoid overfitting during training and to improve model generalization. So this is the ground truth and semantic segmentation output. It's not obvious the difference between ground truth and semantic segmentation output if we only use our eyes. So we need some process to factorize the model first and then try to compare between predicted and the actual pixel level. So this is the loss and accuracy. So at you might see from this table, it seems that training process has been optimum up to 8 epochs, and then after that there is some unexpected result because of the valid loss seems to raise sharply. However, from training accuracy curve, it seems that the model learn gradually during the training process. So the testing confusions matrix can be summarized as the best training accuracy 0.86, average training accuracy 0.85, testing accuracy 0.89, and the predicted Paddy field from Pangko area is 11,000 x 628 hectares. So as conclusion, high performance semantic segmentation model to generate Paddy field map is important, especially in the agriculture field. In this study, we attempted to detect Paddy field from satellite image using semantic segmentation method. Okay, the input locations image is a Pangko area, Kapuas district of Central Kalimantan. And in this study, we explore a variance of PSP-net, a semantic segmentation model that achieved 0.86 base training accuracy, 0.85 average training, and 0.89 testing accuracy, which demonstrate that PSP-net is feasible to be used as semantic segmentation for other multi-class um, pixel classification from satellite image. Okay, so that's all from me. Thank you very much.